Hey students, before I give my lesson, I'm just going to give you some information. Some of it is you've already gotten via Google Classroom or in your email, but I'm just going to give you a couple of items. First of all, hope you're all doing well under the weight of the news that's going on. I've decided to assign regular homework, so there's an assignment tab in Google Classroom where you can do assignments, and I believe you did this with Mrs. Lee. So, yeah, I'm going to assign regular homework that way, and you should be able to turn it in via Google Classroom by taking a picture and submitting it that way, or else just email me a picture of the homework. So it'll take a while to get used to this, but I'm going to start counting it on Wednesday. So try and get your previous homework in that way, and then going forward, take a picture of your homework and then turn it in. Number two, there's a Zoom link in the lesson document, so you can try and connect with me that way. So I'm just going to leave it open during class time. So yeah, let's see if that works. Otherwise, I'm available by GChat or just email me.
The objective for this lesson is to understand more about arcs and what arc length is, and then how arc lengths are related to the degree measure of the arc and the radius of the circle in the arc. And then from there, we're going to come up with the formula for arc length, and after that, we're going to do some work with radian measure. So that's today's lesson. We'll start off with just this question: find the arc length of AB. So the way we do that, first thing is to just figure out the circumference of the circle. And so in the previous lesson, you all got good at calculating the circumference of a circle, and then calculating the radius of the circle if you know the circumference, calculating the diameter if you know the circumference. So as you remember, that circumference equals 2 pi r, so they give you r. So the circumference for this circle is going to be 2 times pi times 9. So when you do the calculation, you end up with 18 pi. So then the next thing you do is just figure out what fraction of the circle is 60 degrees is. So you just divide 60 by 360, and then that gives you the fraction of the circle that arc length represents. So 60 degrees as a fraction of 360 is 1/6. That fraction of the circle will be the arc length that we're looking for over the total circumference. So 60 over 360 equals x over 18 pi. So the next thing we do is just solve for the arc length. So from now on, we're going to define arc length as s. S is the variable for arc length. So if we solve for s, we get 3 pi. So if the radius is 9 centimeters, the arc length for arc AB will be 3 pi inches. Using your intuition, you can figure out the arc length, but we need you to be able to just, not just use your own intuition and boil it down to a formula. And so the formula is that the arc length S for any arc of where M is the central angle can be found using the formula S equals M over 360 times the circumference, which is 2 pi r. Alright, so let's do another problem. This is just a word problem. Feel free to go back and forth and do the homework and refer to this and the Khan Academy and other videos, and just work through the homework that way if you like. But I'm just going to do this next problem. On a clock face, minute hand of a clock is 10 inches long to the nearest tenth of an inch. How far does the tip of the minute hand travel as the time progresses from 12 to 12:15? So the minute hand is the radius, and then as you travel from 12 o'clock to 12:15, that makes a 90-degree angle. So then you've got the variables you need to calculate the arc length. So yeah, just plug it into the S equals M over 360 times 2 pi r. M is 90, R is 10. So yeah, 90 over 360, that's 1/4 of the clock face that is traversed. Then you just multiply that by the circumference to get the arc length. And you get 5 pi inches. If you multiply that out, you get 15.7 inches. All right, so here's another problem. Feel free to work this out on your own. If you like, yeah, pause and then work it out on your own and let me know if you got the right answer, and then I'll go over it. All right. The way we do this one is we just say, okay, the radius. It's the same procedure as the last one. The radius is 6. The angle measure m will be 180. So it's going to be s equals 180 over 360 times the circumference. So 180 over 360 is the same as 1/2. Circumference is going to be 2 pi r. So that's going to be 6 times 2 times pi. And then if you multiply that, you get 6 pi. And then if you feel like multiplying that out, you end up getting 18.85 inches. All right, so the next exercise is what you're going to do is just find the value of a 90-degree angle. Find the arc length of a 90-degree angle for circles with different radiuses. It gives you the first one, so if the radius is 1, then if we use the formula that we just discovered, it's going to be that arc length, the m central angle 90 over 360 times the circumference 2 pi times 1. So if you if you calculate that, you get 1.57 or pi over 2. So next thing we're going to do is calculate the arc length for a 90-degree angle with a radius of 2. So if you do that, you just plug all those numbers into that same formula. So arc length S will equal that same 90 over 360, 1/4, times this circumference, which is going to be 2 pi r. And so that's going to be, the circumference is going to be 2 times pi times 2. So that's 4 pi. So the arc length will equal pi. Now do the same thing for if the radius is 3. Put it back into the formula. 90 over 360. That's 1/4 times the circumference, which is going to be 2 times pi times 3. So that's 1/4 times 6 pi. So that's the same thing as 3 pi over 2. And then put that in your calculator and you get 4.7123. 4. So if you put 4 in for the radius, you end up getting 2 pi. And do the same thing for radius of 5. And then you get what's that? As the radius increases, the arc length increases linearly for the same angle. Okay, so that's how to do all the ones with arc length. So arc length and radian measure are very closely connected. Now might be a time, if you want to just go watch the Khan Academy video on radian measure. It's a really good explanation. But in this little bit, it says, as you discovered and explained too, when the central angle is fixed at m degrees, the length of the arc is proportional to the radius. So, in that one where radius is 1, then the arc length is going to be 90 over 360 times the circumference. So in that situation, if the radius is 1, the arc length will be the same as the radian measure. So radian measure, it's just, it's a different way of measuring out degrees. So 90 degrees is going to be 2 pi radians over 4. 180 degrees is going to be 2 pi radians over 2, so just pi radians. 270 is going to be 300, 2 pi radians times 3/4, so that's 3 pi over 2. So yeah, it's just, this is a good time to get back reacquainted with radian measure. So if, go back to the Khan Academy video and make sure that you understand it before you move on to the last problems that have to do with radian measure. Alright, so for this one, we're going to convert 90 degrees into radian measure. So the way we can do that is just draw a circle and then draw a 90-degree angle, and then you note that the whole around the circle is 360 degrees, and that's the same as 2 pi radians. So you just convert it by saying that 90 over 60 is going to be the same as the radian measure of the angle over 2 pi radians. And then solve for x. X will be the radian measure. So if you do that, you get pi over 2 radians. Now let's say, what if you wanted to solve for 45 degrees and you didn't want to go through all of that? What you could do is just say, use the handy dandy conversion ratio that they give in the book. So if you have degree measure, you can just figure out radian measure by multiplying it by pi over 180. And then when you do that, you get the radian measure for the 45-degree angle, which is 3/4 pi. Alright, and now we're going to, so let's say if you wanted to convert 60 degrees into radians, it's good to go, when you're starting out, just to remember the kind of conversion, why you can use the pi over 180 conversion. So if you do the whole thing of comparing, noting that the fraction is 60 over 360, and that's going to be the same as x radians over 2 pi radians. If you solve for x, you get 1/3 pi or pi over 3 radians. And you would get that same thing if you just multiplied 60 by pi over 180.